Welcome back to second law of thermodynamics and our topic, Gibbs free energy. So what is Gibbs free energy? Gibbs free energy is the energy available to do work, and it is signified by the Gibbs equation. Delta G is equal to delta H minus T delta S. Just like delta S and delta H, delta G's sign convention means different things. If delta G is negative, the reaction is spontaneous and can proceed on its own. If delta G is positive, the reaction is not spontaneous. And this is the reverse of our delta S, so don't be confused. Meanwhile, if delta G is 0, the reaction is at equilibrium. Use this table as a basis for all our calculations, especially when you are determining the spontaneity of a reaction based on your delta S, delta H, and your delta G. So if your delta S is positive and you have a negative delta H and a negative delta G, it is spontaneous at all temperatures. If both delta S and delta H is positive, it doesn't matter if your delta G is positive or negative, it will be spontaneous at high temperatures. And when we say high temperatures, this is temperature above 100 degrees Celsius. And if you have negative S and negative H, the reaction is spontaneous only at low temperature. If delta S is negative, your delta H is positive, and you have a positive delta G, your reaction is not spontaneous at all. So even if it's high temperature or low temperature, it is not spontaneous. Therefore, we could say that it is not physical. So how do we calculate for Gibbs free energy of a reaction? We have two methods. The first one is your direct calculation, and the second one is via your Gibbs equation. So direct calculation is simply delta G is equal to the G of your products minus G of our reactants. While Gibbs free equation is delta G is equal to delta H minus temperature times your delta S. Let's do this example. So determine the delta G of the reaction using the summation of delta G or our direct calculation and Gibbs equation. Question C and question B is to determine if the reaction is spontaneous given the temperature. First, let's calculate for Gibbs using direct calculations. Delta G is equal to the G of your CO2 plus the G of your H2, but we don't have a G for that, so we just immediately remove it from the equation, minus G of H2O plus the G of your CO. Negative 394.4 minus negative 228.6 plus negative 137.2. What will be our delta G? After calculation, our Gibbs free energy is negative 28.6 kilojoules per mole. And if we will just base it on this calculation, we will say that our reaction is spontaneous. Now let's look at the Gibbs free energy using the Gibbs equation. First, let's calculate for your delta H. Negative 393.5 minus negative 241.8 plus negative 110.5. So what will be our delta H? Our delta H is negative 41.62 kilojoules per mole. How about our delta S? So we have 213.7 plus 130.6 minus 188.72 plus 197.5. What is our delta S? Our delta S is negative 41.92 joules mole Kelvin. We have to take note that our equation is delta G is equal to delta H minus E delta S. We now have our prerequisites. Now we could calculate. So delta G is equal to negative 41.62 minus the temperature 25 degrees Celsius. So 25 plus 273.15 to convert it to Kelvin times our delta S, negative 41.92 joules mole Kelvin, and then we convert it to kilojoules. So what is our delta G? Our delta G is negative 29.1216 kilojoules per mole. It is quite different compared with the delta G calculated using direct equation. Probably this is because of the rounding off of values, and the rounding off might have happened during the determination of delta H of your components and the S of the components. But a difference of 0.5 is not that high anyway, so just make sure that when you are calculating, you look into the requirement if you are being asked to calculate using direct or using Gibbs equation. We have two more requirements, which is the reaction spontaneous at 25 degrees Celsius? And is it spontaneous at 2000 Kelvin? So to determine this, you have to refer back to the table that was presented to you earlier. Remember the values that we had calculated earlier? We have a negative delta H and a negative delta S with a Gibbs free energy of negative 29. So where does that fall? It falls under case number 3. So negative delta S, negative delta H. And you have either positive or negative delta G. So the reaction spontaneity is spontaneous at low temperature. So given our two temperatures, 25 degrees Celsius and 2000 Kelvin, which is around 1700 degrees Celsius, is it spontaneous at 25 degrees Celsius? Yes, because 25 degrees Celsius is a low temperature. Now, is it spontaneous at 1700 degrees Celsius? No, because 1700 degrees Celsius is a high temperature. So that's the end of this video. Thank you very much. If you have any questions, please place them on the comment section below.